So quickly, a little bit about me. I'm a customer support engineer here at Seven Signal. Um, my background is mostly enterprise engineering, specifically network side for the most part. I know most network engineers are kind of jack of all trades when it comes to networking, route switch, as well as wireless. I do hold some CWNP certifications as well. Um, so the industries that I have the most experience with are particularly the energy sector. So whether it's mining companies or um, power utility companies as well. I've also worked in the healthcare side of things, retail, kind of a wide gamut of wireless environments that I do have experience with, as well as just overall networking experience. So kind of digging into a little bit about what we're going to be just talking about today, kind of a overview of what channel utilization is, kind of some typical causes of why you will experience some high channel utilization, as well as how to mitigate some of those. And then we'll also talk briefly about how our Sapphire Eye can help you monitor as well as visualize how much channel utilization there is, as well as what's actually causing or what kind of traffic is causing that channel utilization to spike. And then we'll finish with a quick Q&A as well. So first, what are Wi-Fi channels? So the easiest way I can kind of explain it is think of the same thing as like a TV channel or an AM FM channel. It's just a frequency band. That's really all it is. It's just a set frequency. So you can see that the picture there on the top is of the 2.4 gig spectrum. So there's 14 total channels in the US. There's really only 3 channels that we recommend using. 1, 6, and 11. It's the only 3 that are non-overlapping. In other parts of the world, you can use some other channels as well, but typically kind of standard is 1, 6, and 11 to use. And then for the 5 gig, you have 25 total channels, depending on where you are in the world as well. Different regulatory bodies allow use of different channels. And then there in the middle of this chart here, you have the DFS channels. And in particular, these channels are used for radars, specifically weather radar as well. So there are some limitations of what you can and can't do using those channels. Excuse me. So you have 25, 20 megahertz wide channels. You can of course bond some channels as well to get wider channel spread. So instead of 20 megahertz wide, you have 40, 80, or 160. I don't really recommend using 80 or 160 megahertz wide channels in a enterprise environment, but you do have that option. So why should we really care about channel utilization? I found this picture the other day and thought it would be a good kind of illustration, especially since there are 3 different sections of this roadway. It kind of made me immediately jump to 2.4 gig spectrum. So you have 3 different channels type of deal, and then you can see traffic going heavily on this far left section of this road, and then the other 2 are not quite as congested. Same thing with channel utilization. So when we're looking at Wi-Fi, we're looking at how often that channel is being used. So just the percentage of time that that 20 megahertz wide spectrum is having traffic being sent across that frequency. Now that can be Wi-Fi traffic, it could be neighboring Wi-Fi traffic, but it can also be non-Wi-Fi traffic. So it can be Bluetooth, it can be other forms of interference as well. And why we should really care about these numbers is the same thing as you're in a car and you're traveling down the road. If it gets heavily congested with lots of users, your speed is most likely going to be decreasing. Same thing with Wi-Fi. As the channel utilization increases, the more you use it, the lower performance you're going to have. So your client throughput is reduced as the channel utilization increases. There's potentially packet loss as well. You can have, at the more extreme cases, you can have clients that just disconnect completely from the Wi-Fi. And at the very extreme side of things, you can have clients that are just completely unable to connect to the wireless environment altogether. And then you have that classic client just says, "Hey, the Wi-Fi is broken." That's all you get from the end user, is that it just doesn't work. So then you have to dig into actually what is going on and troubleshoot further. So some things that can cause channel utilization to increase. If you have a poor channel plan, so like if you're using 2.4 and you're not using 1, 6, and 11, you're using some standard or some non-standard channel, and you're having overlapping channels, that can cause an increase in your channel utilization. If you're using 40 megahertz wide 2.4 channels, for example, you're going to be causing some issues there as well. If you have a very large number of SSIDs, so each SSID has to send out a beacon. And if you have 10 plus SSIDs that you're broadcasting at a time, each one of those SSIDs by default sends a beacon out every roughly 10 times a second. So if you have 10 of those, you can see how quickly that number increases, and then your channel is being utilized just from your beacons, just from you advertising what networks you have available. Another thing that can increase channel utilization is interference in the area. If you have a very large amount of Bluetooth traffic, for example, is going to cause interference in the 2.4 spectrum. There can be all sorts of other different types of devices as well, causing interference in both 2.4 and 5 gigahertz spectrum, as well as legacy devices. So those older devices that run at slow data rates, your 802.11b devices, for example, if they're running at say 1 meg per second, you're going to have to wait for that client to finish its data send before the next client can have access to the medium. So in wireless, only at the very core of it, only one device is allowed to talk at a time. So that's something you really need to be aware of, and how you're only as fast as your slowest client, more or less, at that point. So in terms of channel planning, you want to avoid some overlapping channels. I took some screenshots from our Sapphire Eye platform. So we do network scans and scan for access points on different channels. And you can see here all of these different APs that are broadcasting and overlapping these other access points are going to increase that channel utilization for both of those, or all of those networks that they're overlapping, which is why you want to use 1, 6, and 11. So we have kind of a standardized kind of environment, so we don't have to worry about overstepping somebody else's network. You want to be a good neighbor. You don't want to cause issues for other people, the same way you don't want other people to cause issues for you. And you don't want to use 40 megahertz wide channels in 2.4. You're going to be causing more issues than you're going to solve with that increase in throughput. You're just going to have way too much interference at that point. And then the same thing with 5 gigahertz. Obviously, we have way more channels available than we do on 2.4, but at the same time, it's still something to note as well. In particular, if you're not using the DFS channels, you're limiting yourself from having 25 available channels to only 8. So you're kind of still having that same issue that we had in 2.4. And as you're deploying more more capacity driven, more dense deployments, and having way more APs, you're going to want to limit your channel width to allow that access to the more available channels. You're not having an increase in your channel utilization just because you're overstepping either your own self or your neighbor as well. And one thing to point out too is whenever you're using those wider channels, the management traffic, so like the beacons that are being sent, probes, and all of that good traffic there, with kind of how Wi-Fi works, it only is being sent on the primary channel, so they don't use the full 40 or 80 or 100 megahertz wide channel. They only use that primary 20 megahertz wide channel for that type of data. So one thing to note about that is that if you're looking at the full the full channel you're using, say an 80 megahertz wide channel, that primary channel of is always going to have an increase in channel utilization than the other corresponding channels that are bonded together. And speaking of those beacons, I kind of like to think of channel utilization as more of just a number. It's not something that I typically use for troubleshooting. I think it's a good starting point. But the way channel utilization works, and what I'm meaning when I'm saying channel utilization, if you look at this chart here, it's the number that is being broadcasted by the access point itself. So with 802.11e, that amendment introduced some QoS settings, and they added the ability to broadcast how busy an AP detects the channel that it's broadcasting on. So that's what we're seeing with that number in terms of channel utilization. We don't actually know what traffic is being sent when we see that number. So if you look here, these numbers, and again, these are charts from our Sapphire Eye product, but this number shows just overall traffic. That could also include non-Wi-Fi interferers as well. So I highly recommend using more protocol analysis to determine what the traffic is. That way you can kind of dig deeper into it to determine how much of that channel utilization is actual Wi-Fi traffic. And the good thing about our Sapphire Eye product too, and you can do this with a Wireshark capture as well. You can do this with all sorts of different products, but you can capture the traffic and then load it up in Wireshark, for example, and then determine what are the wireless frames that we're seeing. So you can see here that this is from a 2.4 spectrum. I believe this is from inside of a mall area. So there's obviously lots of other surrounding access points, all sorts of different clients in that area. And this is the actual Wi-Fi frames that are being sent. So we're at a 25%, is where my mouse is here. But what's interesting is of that 25%, 20+% of it is just beacon frames. So this is where it gets more. This is how you get more information, is you're seeing these beacon frames that are being sent out, and this access point in particular is broadcasting, I believe it was like 12 different SSIDs. So you want to limit your SSIDs. I recommend at the maximum no more than 5. I think it's pretty standard to say 3 or less is what we are looking for. But you have to remember the beacons are sent out every 102 milliseconds, give or take. It's a range of 100 to 300 milliseconds, depending on how it's configured. But each SSID sends a beacon out. So the more SSIDs you have, the more management overhead you are sending. And our thing to note too is beacons are always sent out at the lowest mandatory data rate that's configured. So if you have 1 meg set as your lowest mandatory data rate, all of those beacons are being sent out at that slow speed. So essentially, it's like somebody is walking a horse down the interstate. So all of your high speed traffic is being held up by all these beacons that are being sent out. So that could be part of these issues that you experience whenever you have high utilization. And then another thing too are probe requests. So if you are hiding your SSIDs, your clients will have to send out probe requests to find what APs are broadcasting those networks that they're looking for. And if we tie this back into that DFS question and DFS earlier, because it's using weather radar, clients are not actually allowed to send probe requests on DFS channels. So if you're using DFS channels, you really don't want to be hiding your SSIDs because you're going to be causing clients to not be able to find access points to connect to. But in addition to hiding your SSID, you're going to, if you do end up doing that, you're going to be increasing your channel utilization just because clients are going to start sending probe requests and access points are going to be responding to those. So you can see here that our probe response just from the access point is also increasing our channel utilization depending on how many networks you're broadcasting, if any of them are hidden. This is the same environment from the previous slide. So you can see that during the day when clients are in this particular store, our channel utilization, just because they have some APs that are hit or SSIDs that are hidden, channel utilization goes up by 10 plus percentage just because they have SSIDs that are hidden. Another thing too is interference. Specifically in 2.4, we primarily see it the majority of the time with Bluetooth, where it's hopping across the entire spectrum, can cause that average utilization that's being monitored by that AP to then increase. And what's nice about having that channel utilization calculation from the AP, and then also using a protocol analysis tool, you can quickly see if potentially there are some interference in the area. You can take the channel utilization that's reported by the access point versus the airtime utilization that you're getting from analyzing the wireless frames and compare that data. So you can see here that we're seeing channel utilization at 65, 70% of the channel being used. But in terms of Wi-Fi traffic, we're only seeing 25%. So that's a pretty good indicator that there's some type of non-Wi-Fi traffic being sent on that channel because there's a large difference in those numbers. So it's a nice quick way of seeing, okay, you might be having some type of interference in this area. And then back to the data point or the data rate example, I saw this photo as well. If you've ever been on like an old country road and you're stuck behind a tractor, you kind of know how frustrating it is. You're wanting to go much faster, but you're stuck behind this slow moving vehicle in front of you, and you can't avoid it. And it's the same way with Wi-Fi. If you have a device that's communicating at a slow data rate, but yet you're at a much higher data rate, you're still waiting for that slow device to finish its communication before you can. And this is a nice chart too that we have that shows different clients and the percentage of time that they're connecting at certain data rates. So you can see here that there's one client that's always connected to an AP at 12 meg per second, where you have these other clients over here that are 300, 400 meg per second devices. So they will have to wait for that 12 meg device to finish communicating. And then some ways that you can kind of mitigate or kind of help alleviate some of those high channel utilization. Like I said previously, you want to use 1, 6, and 11 for 2.4. If you're having high channel utilization and you're using wide channels and 5 gigahertz, think about going to 20 megahertz wide channel or changing from 80 to 40 to see how or if that alleviates some of your issues. You also want to limit the number of SSIDs that you're broadcasting. Like I said, 3 or less is what we want to look for. If you have to have more, I would not recommend more than 5. The higher or the more SSIDs you have, the more management frames are being sent and the more beacons that are being sent. And it just slows down everything because, like I said previously, they are always sent out at the lowest mandatory data rate that you have configured. You don't want to hide your SSIDs for the same reason that increases probe requests and probe response traffic as well. So it adds unnecessary overhead to your traffic. As I'm sure many of you know, there's no real security reason to hide an SSID either because it's sent in plain text within the frame. So if you're capturing that data, you're still going to see the SSID. Another thing you can think about doing is adjust your transmit power on the AP. So if you have a very large cell, you can kind of narrow that in so you're not overstepping your other access points. You're not causing yourself interference in terms of an AP interfering with a neighbor AP, that type of thing. And if you're noticing that you have very high beacon channel utilization, a thing you can think about doing is increasing the beacon interval from the 100 milliseconds up to 300 milliseconds. Now, there is a caveat to this. There are clients that will have issues connecting to your network if you increase that beacon interval, specifically older legacy devices. Think like, I believe some of those VoIP devices, like those old Vocera devices or older Vocera devices in hospitals are a prime example of a device that you don't really want to increase the beacon interval. And I'm sure Jim has kind of some color to add to that as well, but it's very heavily dependent on what clients you're supporting.
Yeah, that's a concern. I think our healthcare customers relay a lot to us about altering the beacon interval. No, I know I've got this 10-year-old, 15-year-old client that's just not going to handle it well. So something to consider if you're looking at that.
Yeah. When I think of increasing beacon intervals, I'm mostly thinking of like high capacity, maybe like open areas like an arena or something, to where you're not necessarily worried about supporting older legacy devices, but you have kind of a large open space to where there's not a whole lot of barriers in between your APs. So if you can limit how many beacons are being sent in the air, it will help in that regard.
Yeah, that's a good environment too, because they're not really concerned with roaming performance. Most people are just, sitting in their seat when they're using their devices. They're probably, hopefully not using them as they're walking through the concourse. Of course they are, but it's not as important a use case. And because the other consideration here is AP discovery during roaming. And if APs aren't beaconing as frequently, then there's a possibility a roaming client may not at least passively discover that AP as quickly. And then it becomes more dependent on active probing to discover APs. So a couple considerations there.
Yeah, it all comes back to knowing your environment, knowing your clients, and planning accordingly. Some other things you can do, speaking of legacy devices, you can disable some of those lower data rates, completely disabling 802.11b support. Disabling those lower data rates will speed up how quickly your beacons are being sent out. Another thing is turn off radios or turn off devices that are broadcasting their own networks if the wireless with those are not being used. A good example are printers. So I'm sure everyone's aware of having a printer installed in an office and they're sending out their own network, broadcasting their own um, wireless at that point. And they are sending out beacons. So they're sending out 10 beacons um, a second at that point, more or less, causing you to have increased not only interference but increased management traffic being sent on a channel. So just something to note. And then kind of some ways that we can help, and some ways that you can look at this. If you are a Sapphire Eye customer, there's some KPIs that you can look at specifically. These are some of those reports that I was showing earlier. But all this is just protocol analysis. So we're just graphing it and showing you the different um, that different traffic. So instead of looking at the channel utilization that's being broadcasted by the AP, so that's that QPSS channel utilization, you can dig farther into it. You can look at how much airtime is how much of the wireless traffic specifically is utilizing airtime. What percentage of that is management traffic? What percentage of that is data traffic, control traffic? Excuse me. You can break up how much of that traffic is beacons, how much of it is probe requests, probe responses. So there's some good KPIs to use and kind of troubleshoot these utilization issues that you may be experiencing. And what's nice too is you can get kind of like a baseline of how things are performing. So if you're having utilization issues, you have a nice steady graph of what your environment's like. And then as you make changes to kind of mitigate those issues, you can then use that same data to compare, contrast, and kind of track how things are improving, if they are improving, and just improving your client experience at that point. So that's about it. So we can move on to some questions if anybody has any. So
Yeah.
some Q&A.
Yeah, nice job, Jack. And one important takeaway for me is, we can't just look at that channel utilization number and understand if our Wi-Fi is healthy or if there are problems or not. You can have a situation where channel utilization is really high, but actually we're using high data rates, our management overhead is low. It's just a really busy network at that point in time. Maybe my Mac is downloading some enormous OS update and it's just pulling a ton of data from the AP. And so the channel utilization is high. Well, that's perfectly normal. That's a healthy network. But, certainly there are circumstances where high channel utilization is problematic because there's a lot of CCI, it's all beacon and probe, and it's really limiting the ultimate performance the network could provide. So you really got to, look into the next layer of protocol analysis to really understand, if you've got problems or not. So with that, a couple good questions came in. Want to invite anybody else in attendance to drop a question in the Q&A panel. Really interesting question here from Wojciech, I believe, who says, and I will simplify this, are you allowed to send a probe if you see a beacon with a hidden SSID on a DFS channel? So that is a CWAP level question for you, Jack. I think I have an answer, but what do you think?
In terms of clients, they are not allowed to send probe requests on DFS channels. They have to passively scan.
So the interesting thing here is he says, if you see a beacon, and I think in some circumstances, you can send a probe, the client can, after it's heard a transmission from an AP on the channel. Although that's probably dependent on the regulatory environment you're in. but I think whether the SSID is hidden or not is not important. And in fact, it doesn't have to be a beacon. It could be a data frame. It could be anything from an AP operating on the channel would allow the client to probe. What a client can never do on a DFS channel, though, is blind probe, which is show up on the channel, not listen for anything, just send a probe like it would on a non-DFS channel. So I believe that's how that works. Anybody who wants to chime in in the chat is
I'd
welcome
have to double check after it's seamed, or after it has seamed other traffic, but it cannot actively scan. It has to only passively monitor in DFS channels.
Yeah. Okay, so another good question from Bruce. He says, can you speak to disabling lower data rates to reduce cell size? Is it better to disable lower data rates or lower transmit power on the APs? What do you think, Jack?
In my opinion, it's always better to lower or to disable lower data rates, because you're removing support for those old legacy devices, and you're increasing speed at which that all of that management traffic is being sent. Now, in terms of reducing cell size, it's kind of the same principle. The lower the data rate, the farther signal goes. So I would start with the data rates if you can. If you can't get rid of those legacy devices, that's where you're limited in how you can reduce cell size.
Yeah, and just to add to that, when you lower the transmit power from the AP, you're lowering the SNR the clients receive. So, that could have a negative impact if it's taken too far. So, disabling those lower data rates is definitely a good first step. And one last question here from Andrew. He says, on the same page as the beacon interval is the fragmentation threshold. Is there any major benefit in lowering this value? The default is the maximum. Any thoughts there, Jack, on
I don't have a lot of experience messing with fragmentation threshold.
Yeah, and I think perhaps he's actually asking about the like the maximum TX op size or the maximum AMPDU size, which would, potentially break up the amount of airtime a client can utilize at any given time. In terms of channel utilization, more aggregation is more efficient and uses airtime more efficiently. But in terms of allowing more frequent channel access to clients like VoIP clients that you don't want to have any delay there, it can have a negative impact. So in general, I would say look at the reference design guides from if you have VoIP clients on the network and see what the vendor suggests in terms of those values. And maybe one follow-up from Wojciech. He asked about the probing on DFS channels. He says, is it allowed for an AP to ignore broadcast probes? I think that is allowed. What do you think, Jack?
I believe so.
Yeah, I think so. It could be, again, could be problematic for your clients that are they're set in their ways, and that may be how they go about discovering APs. But I believe that is allowed. Yes. Okay, and with that, I think we're about at time. Nice job, Jack and Heather. We can transition.
Awesome. And you see Eric Muley pop up on the screen. You know what time it is. It is time for 7 minutes with 7 signals. So Eric, without further ado, take it away.
Yeah, that's great. I'm going to share my screen now. Hold on just a moment. We learned so much today from Jack with regards to channel utilization. Awesome, awesome stuff. You know, how do you know if you have a congestion issue? I mean, we talked about how congestion issues can be really, really bad, right? They could really cause slowdowns. So how do we know? You've got to measure. You've got to create a baseline. Once you have a baseline, you need to monitor. And once you monitor, you can identify. And then after identifying, you can mitigate. Okay, but it all starts with measuring. You can't manage what you can't measure. And so let's take a look at Mobileye here and see what I'm talking about. So this is my device, as you can see here on the screen. And from my device's point of view, this is my device performance. As you can see, I'm grabbing out of the air the channel utilization from the beacon. And you can see that I'm reporting this on the screen. And I can baseline because I'm taking a measurement every few minutes. So you can see here, every few minutes, there's a measurement. Along with that, you can also see the client count, which is also coming from the beacon. So I can correlate that. Okay, does channel utilization increase, and does that correlate to the number of clients that are also on the same access point that I'm on? Maybe, maybe not, right? It depends upon what those clients are doing. Not only that, but when there is an increase in channel utilization, like Jim and Jack said earlier, it doesn't necessarily mean that there's some kind of performance impact. Again, how would you know? Well, Mobileye every few minutes is doing a quick little speed test. And so you can see how we're correlating it over here to download throughput. So even though channel utilization is getting what might be considered a little bit high for a moment, at about the same time I did a speed test, a throughput test, and I was achieving 73 megabits per second, not necessarily anything that's going to cause alarm. Why? Because the metric is being correlated to the user experience, and speed is one of the best user experience metrics that we can offer. Now, one more thing that I want to show you guys here. So down here, as you can see, we're drawing a picture of all of the Wi-Fi networks that are all around us. And look at this, guys. You can actually see that bumper to bumper traffic that Jack was talking about earlier. You know, for example, this could be the tractor. This could be walking the horse down the interstate. And then you've got these other people on these other networks that are also trying to use that lane or frequency or channel on the highway. And they can't do it because of the potential issues that are taking place. So it's really neat to be able to see these other networks that are not mine. You can see this is one network. This is a second network. This is a third network. Okay, and without seeing this from my device's point of view, it's invisible. I don't know it's there, but now I do. The other thing I wanted to share with you guys here is that I can get a printout of all of this information just by clicking the little download icon right here. So let's bring that up. And this is just a wonderful way to see everything that's going on around my computer. Let's do that again. Right here. There we go. Okay, here we go. Let's take a look at this and I'll show you exactly what I mean. Here it comes. There we go. Okay, check this out, guys. So let me open up all of these columns for you. And when I do, you can see this is every single SSID that's being broadcast around my computer. And you can also see the channel that it's on. You can see the channel utilization also. Now check this out, guys. As I get down here, all of these are all the 5 gigahertz networks, but look at this. As I go down to these 2.4 networks, look at the jump in channel utilization. Is that unbelievable how you can see that jump right there? It's just a fact, right? Less lanes on the highway means there's going to be more congestion. So there you have it, guys. That's what I wanted to show you guys today. And hopefully, you know, you guys get a flavor for how important it is to both monitor your Wi-Fi network using systems like these, and then so that you can take steps in order to mitigate. So there you have it. You know, just want to remind everybody out there that, you know, we can't see, we can't hear Wi-Fi networks, but 7 Signal can. Thanks for joining us today, everybody. Have a great one.